Hello, my name is Earl Apolanis. I'm a technical marketing engineer here at Brocade. Today we're going to talk about our VCS Fabric technology for cloud-optimized data centers. What makes VCS unique from classical Ethernet is the ability to utilize all your bandwidth with minimal configuration. If there are three things to highlight about VCS, the first would be that it uses standards-based protocol TRIL to eliminate the use of spanning tree. The second is that it's self-forming and auto-healing. Simply connect two VDXs together and the fabric is formed. The third is intelligence. VCS is aware at all times where MAC addresses are located in the fabric, the shortest paths to get there, and exactly how many there are. VCS also presents itself as a logical switch to other network devices. In summary, it's a network that just works. I'll show you what we mean when we plug the two VDXs together. So here we have two brand new VDXs. We're going to take this one out of the box and we're going to start configuration. What we're going to do is we're going to configure the VCS and R-bridge IDs to form the fabric. Simply provide a VCS and R-bridge ID for each switch followed by a reboot. Now that we've configured the VCS and R-bridge IDs, we're going to form the fabric. There's no CLI needed. Essentially just plug it in and the fabric forms. So there you have it. There's nothing more simple than two VDXs and a single connection between them to form a fabric. So now that the VCS fabric is formed with a single ISL between the two VDXs, we're going to form a Brocade trunk, essentially aggregated bandwidth, simply by adding another connection. What we've just done here is create a Brocade trunk. We've grown the 10 gig connection to 20 gig connection. And we call this a Brocade trunk as opposed to a lag known in classical Ethernet for aggregated bandwidth. The difference between a Brocade trunk and a lag is that there's no hashing algorithm used within a Brocade trunk. We evenly distribute the I/O across both physical links. Okay, next I'm going to show you the VM Aware Network Automation feature of the Brocade VCS fabric. So for this portion of the demo, we're going to show you how VCS integrates with hypervisor technologies such as VMware. Typically, coordinating with the server and network teams have been a sticking point in the successful deployment of VMs. So VCS is instantly aware of any newly deployed VMs, what their MAC addresses are, the locations in the fabric, any VLAN ID settings or QoS. So for example, if a VLAN created in vCenter doesn't exist in the fabric, VCS automatically pulls that VLAN ID from vCenter. The VM Aware Network Automation works by seamlessly integrating the VCS fabric with vCenter. Newly created VMs are auto-discovered by the fabric along with their network policies. Implementation of this feature is simple and only takes one configuration on any switch in the fabric. Discovery of VMs and their network policies is automatically propagated and occurs behind the scenes. A port profile is also created for the new VMs to ensure that those network policies are applied to the VM regardless of its location in the fabric. In this demo, we're going to create VLAN 800 in vCenter and deploy VMs into that VLAN. Prior to the creation of VLAN 800 in vCenter, it does not exist in the fabric. Upon creation of VLAN 800 in vCenter, the VCS fabric detects the newly created VLAN through the vCenter integration feature and creates that new VLAN in the fabric. Once the new VLAN is discovered and created by the fabric, our AMPP feature creates a port profile that associates the MAC of the VM to the VLAN ID it belongs to. In the event of a vMotion of that VM, the port profile with the VLAN ID is applied to the VM immediately, ensuring continuous network connectivity. So in this example, we'll show you how VCS automates all of these tasks. Here we have vCenter with two ESX servers. On the first ESX server, we have VMs 1 and 2 on vSwitch 2. On the second ESX server, we have VMs 3 and 4 on vSwitch 2 as well. What we are going to do is create a new port group and VLAN from vCenter, move VMs 2 and 4 into that new VLAN, and show you how seamless this process is for the VCS fabric. First, let's examine the state of vCenter with VCS. As you can see, there is no vCenter configured at this time, and we have these existing VLANs in the fabric. Next, we are going to discover the vCenter server from the VCS fabric. Simply add the IP address and login credentials for the vCenter server so the fabric can go through the process of discovery. Next, we are going to activate the vCenter discovery and provide it with an interval of 1 minute. Once VCS discovers vCenter, if any of the virtual assets are modified, like adding or deleting VMs or VLANs, the fabric detects those changes and configures the fabric accordingly. Now let's check the status of the discovery. This discovery took a little over a minute, so we're going to cut to the section where the discovery was successful. Now that the discovery is successful, let's look at what VCS has gathered from vCenter. Here we see the 4 VMs between both ESX servers have been pulled into the fabric. As the output reads, you know which ESX host the VM currently resides on. Let's examine which VLANs currently exist in the fabric. Note that the ESX hosts are on interface 1/0/5 and 1/0/6, both belonging to default VLAN 1. Next, let's verify all of the existing port groups discovered from vCenter. Here they are. Then let's take a look at the MAC address table. Here you can see exactly where the existing VMs are located and which VLANs they belong to. At this point, we are ready to make modifications in vCenter so those changes can propagate into the fabric. Let's go to vCenter and select the first ESX host. From ESX1, go to the Configuration tab, select Add Networking, then we're going to create a virtual machine port group. Then we're going to select vSwitch 2, then we're going to create a port group labeled VCS Demo and provide it with a VLAN ID of 800. Let's repeat those steps for the other ESX host as well. The next step is to move VM2 on ESX1 onto the new port group and VLAN, and do the same thing for VM4 on the ESX host 2 as well. For this part, we're going to right-click on the VM, edit settings, change the network label to the VCS demo that we created, which belongs to VLAN 800. Do the same thing for VM4 as well. Now we're going to check connectivity between the two VMs across the fabric, as VM2 is on ESX host 1 and VM4 is on ESX host 2. Now we're going to ping across the fabric between the two VMs. Now that we know the pings have been successful, we're going to show from VCS what the fabric has discovered from vCenter. Next, we will check to see that the new VLAN created in vCenter is now in the fabric. Here you see that VMs 2 and 4 now belong to VLAN 800, as this was successfully learned in the fabric. From this output, you see that the VCS demo port group we created in vCenter is listed, indicating that it belongs to VLAN 800. To finalize this demo, we will perform a vMotion of one of the VMs to show you how the port profile is applied to the VM wherever it is in the fabric. In this case, the port profile is the VLAN ID that was created from vCenter and propagated into the fabric. Here we are moving VM2 across the fabric while it is sending traffic to VM4. As you observe the VM2 pings on the right during the vMotion, you see that there is no loss of connectivity, indicating that the port profile with the VLAN ID was applied to the VM. This concludes our demo. Thanks for watching.